Hello everyone, welcome to AIT Tech Talk. My name is Narala Siddhartha. My roll number is 20951A6744. Today my subject is cloud computing tools and techniques. So I am going to discuss about edge computing. So, what is an edge computing? Edge computing is a networking philosophy focused on bringing computing as close to the source of data as possible in order to reduce latency and bandwidth use. In simpler terms, edge computing means running favor processes in the cloud and moving those processes to local places such as on a user's computer, an IoT device, or an edge server. Bringing computation to the network's edge minimizes the amount of long distance communication that has to happen between a client and server. So, edge computing represents a decentralized approach to data processing, emphasizing the placement of computation resources closer to the point where data is generated or consumed. In contrast to traditional cloud computing models that conceptualize data processing and storage in remote data centers, edge computing distributes these functions to the edge of the network, which can include devices like IoT sensors, industrial machinery, or even smartphones and autonomous vehicles. This proximity to the data source offers several advantages, most notably reduced latency and improved bandwidth efficiency. By processing data locally at the edge rather than transmitting it to the distant data centers, edge computing minimizes the time it takes for data to travel back and forth, thereby lowering latency and improving responsiveness for time sensitive applications. This real time or near real time processing capability is particularly valuable in scenarios such as autonomous vehicles, industrial automation, and remote healthcare monitoring, where split second decisions can have significant implications. Furthermore, edge computing optimizes bandwidth usage by filtering and analyzing data locally before transmitting only relevant information to centralized servers. This not only conserves network resources but also information to centralized servers. This not only reducing the volume of sensitive data traversing public networks. Additionally, edge computing architectures can provide scalability and resilience by distributing computing tasks across multiple edge nodes, enabling systems to adapt to fluctuating demand and mitigate the impact of hardware failures or network disruptions. So, in essence, let's discuss about what the edge computing in detail. So, in essence, edge computing represents a paradigm shift in how we approach data processing and analytics, offering a distributed, efficient, and responsive alternative to centralized cloud computing. Its adoption spans various industries, including manufacturing, healthcare, transportation, retail, and telecommunications, where it supports a diverse range of applications such as predictive maintenance, remote monitoring, real time analytics, and impressive experiences. As the Internet of Things IoT continues to proliferate and demand for low latency, high performance computing grows, edge computing is poised to play an increasingly pivotal role in shaping the future of digital infrastructure and services. So let's discuss what the network edge is. For internet devices, the network edge is where the device or the local network containing the device communicates with the internet. The edge is a bit of a fuzzy term. For example, a user's computer or the processor inside of an IoT camera can be considered the network edge, but the user's router, ISP, or local edge server are also considered the edge. The important takeaway is that the edge of the network is geographically close to the device, unlike origin servers and cloud servers, which can be very far from the devices they communicate with. The network edge refers to the outer boundary of a network where it interfaces with external systems, devices, or users. It marks the transition point between the internal network infrastructure and the external world. typically comprising endpoints such as end user devices, IoT sensors, gateways, and access points. The network edge is where data enters or exits the network, whether it's traveling to or from the internet, other networks, or connected devices. So, from a geographical perspective, the network edge can encompass various locations including branch offices, remote sites, data centers, and cloud environments. These points of presence are strategically positioned to optimize network performance, minimize latency, and ensure efficient data transmission between users and services. Moreover, the network edge plays a crucial role in determining how data is processed, stored, and secured. With the proliferation of edge computing, computational resources are increasingly being deployed at the network edge to enable real time or near real time processing of data closer to its source. This approach reduces the need to transmit large volumes of data over long distances to centralized data centers, thereby enhancing performance, reducing latency, and conserving bandwidth. In summary, the network edge represents the boundary between internal network infrastructure and external connections, serving as the entry and exit points for data traffic. Its strategic placement and evolving role in facilitating edge computing underscore its importance in optimizing network efficiency, enhancing user experience, and supporting emerging technologies and applications. So, what's the difference between edge computing when compared to other computing models? So, let's discuss. The first computers were large, bulky machines that could only be accessed directly or via terminals that were basically an extension of the computer. With the intervention of personal computers, computing could take place in a much more distributed fashion. For a time, personal computer was the dominant computing model. Applications ran and data was stored locally on a user's network or sometimes within an on premise data center. Cloud computing, a more recent development, offered a number of advantages over this locally based on premise computing. Cloud services are centralized in a vendor managed cloud and can be accessed from any device over the internet. Edge computing distinguishes itself from other computing models through its decentralized approach to data processing and storage, which prioritizes proximity to the point of data generation or consumption. In contrast to traditional cloud computing, which centralizes these functions in remote data centers, edge computing distributes computational resources to the edge of the network. This localization minimizes latency by reducing the distance data much travel, ensuring quicker response time for time sensitive applications like autonomous vehicles, industrial automation, and real time analytics. Moreover, edge computing optimizes bandwidth usage by filtering and analyzing data locally before transmitting only pertinent information to centralized servers. This approach conserves network resources and enhances privacy and security by limiting the volume of sensitive data transmitted across public networks. Okay, additionally, edge computing architectures offer scalability and resilience by distributing computing tasks across multiple edge nodes. This enables systems to adapt dynamically to changing demand and mitigate the impact of hardware failures or network disruptions. Furthermore, edge computing enables real time or near real time processing of data, a capability particularly vulnerable for applications valuable for the applications requiring rapid decision making. By processing data closer to the source, edge computing enhances the overall efficiency and performance of the applications across various industries, including manufacturing, healthcare, transportation, real time, and telecommunications. Overall, edge computing's decentralized, efficient, and responsive nature sets it apart as a pivotal computing model capable of meeting the evolving demands of modern applications and services. Okay, so to summarize, Early computing, decentralized applications only running on one isolated computer. Personal computing, decentralized applications running locally. Cloud computing, centralized applications running in data centers. Edge computing, centralized applications running close to users either on the device itself or on the network edge. What is an example of cloud computing? So let's discuss it. Consider a building secured with dozens of high definition IoT video cameras. These are dumb cameras that simply output a raw video signal and continuously stream that signal to a cloud server. On the cloud server, the video output from all these cameras is put through a motion detecting application to ensure that only clips featuring activity are saved to the server's database. This means there is a constant and significant strain on the building's internet infrastructure as a significant bandwidth gets consumed by the high volume of the video footage being transferred. Additionally, there is very heavy load on the cloud server that has to process the video footage from all the cameras simultaneously. Thank you.